know, so let me do like a short introduction. So first, let's kind of motivate why do we need like what is like polar coordinates. Let's take Cartesian coordinate system, so x and y. And for this Cartesian coordinate system, we're going to choose a point xy inside it. So that the point is xy because if you want to reach this point, you basically tell yourself, okay, so I want to move x amount of coordinates along x-axis and y amount of coordinates along y-axis. So you're going to take this path over here. But the same way, like someone else can tell you, oh, like it's not inefficient, you can just go straight forward to that point. But when you're going to straight forward, do you see like we're going to cover, instead of x and y, we're going to cover like this length, and I'm going to call this length r. But for example, if you're going to stand on this point at the origin, and I'm going to just tell you, okay, you need to reach point xy if you're going to go by r units, but then you're going to ask which direction do you need to go? Because if I'm going to go by r units from the point 0, then I have infinitely many directions. So that's why you also need to fix an angle, theta. So do you see right now, basically the idea is if we have a Cartesian coordinate xy, you can reach the same point by just specifying what distance you need to go using the straight ray and what angle are you going to make with the x-axis. So in other words, xy is going to be equal theta and r. So in other words, polar coordinates are going to be the coordinates where every point inside your plane is going to be described using the distance from the origin. Distance from the origin. And the angle with x-axis. With x-axis. So for example, let's do, where is it? Have it somewhere. Okay, let's do the following point. Let's take point 1, 1. So can anyone tell me what is going to be your theta and what is going to be your r in this case? So theta like 45 degrees or 45 degrees, get used to how it's called, like radians. It's going to be pi over 4, and r is going to be root 2. And why do we know that? Because every time if we have x component and y component, and we have this r, since this angle here is a right angle, we have the formula that r squared is equal to x squared plus y squared. Yes. So in other words, if I want to find this r over here, then r is going to be equal to square root of x squared plus y squared. But there, each x and y is 1. So I'm going to have 1 squared plus 1 squared. So it's equals to square root of 2. So you can see right now how x and y and r are related to each other. So if you want to find r, if you have x and y, then you just need to use this formula here. Okay, and can anyone tell me what about angle? How did you figure out that angle is? Then I know the tangent of theta is going to be equal to y over x. So the opposite side to adjacent side. And sorry, I lied. This should be a red box. So these formulas you need to remember. And so in this case, my tangent of theta is, so this is my theta. I have tangent of theta is equal to 1 over 1. So it's equals to 1. So, but tangent of theta when it's equal to 1 is going to be exactly like pi over 4. So it's answer here. Okay, so this how you find the coordinates, how you go from Cartesian coordinates to polar coordinates, just using this formula. So let's say from Cartesian to polar. Before we're going to move on to the next section, let's do a couple of practice problems. So example 1. So for this example, can you please sketch the following 3 points? So the first point is pi and 1. The second point is pi over 2 and 2. and the third point is pi and -1. We have angle. So that's why, imagine that you have a small vector here, and I'm going to rotate this vector by angle pi. So my point is going to be somewhere along this x-axis, you see? And then I have 1. So that means when I'm going to take the small vector and rotate around the origin, then I'm going to move along that direction by 1 unit. So this is 1 unit, and this is pi. So that's why this is going to be, let's say, my point A. Okay, then using the same idea, I can find next point. I'm going to rotate by pi over 2. And I'm going to walk distance 2 from the origin. So this is going to be 1, this is going to be 2. So this is going to be my point B, which is pi over 2 and 2. Okay, and point C is slightly tricky. So I'm going to do the same rotation around the origin with pi. But do you see I have -1? So can anyone explain what do you do with that negative? Yeah, so instead of walking along the direction, because when we rotate the vector points this direction here, like small, like real small one. I'm going to move to the opposite side. So that's why it's going to be -1c. So c is pi of -1. So you can see like positive r means you rotate your vector and you move along that vector. Negative r means you rotate your vector and you move backwards. Okay. So this about sketching, but what if we have right now this Cartesian coordinates, sorry, these polar coordinates, and we want to find Cartesian one. So example, polar to Cartesian. So let's find the corresponding Cartesian coordinates of points A, B, and C. So for that, remember that if we have this point, let's say theta and r, can anyone tell me how to find your y component and how to find your x component? What is going to be your x and what is going to be your y? If you're going to take a look at this triangle over here, then what is going to be my cosine theta? Cosine theta is going to be adjacent side, which is x, over the hypotenuse, which is r. So I'm going to have x over r. So if I'm going to multiply both sides by r, I'm exactly going to get this formula over here. Okay, and then let's just do one point, I don't like to save time. Can anyone tell me what are going to be the coordinates of the point C? What are going to be the Cartesian coordinates of the point? I'm going to have x and y is equal to -1 cosine pi, and this is going to be -1 sine pi. So then my x is going to be equal to -1 times -1, which is 1, and my y is going to be equal to 0. So that's why I'm going to have 1, 1, 0, and that is exactly the point over here. 1, 0. Yeah. So here I want to discuss one remark. So let's take, let's say this point 1, 0. Can anyone tell me what is going to be the polar coordinate of that point? The same point inside the plane have a unique Cartesian coordinate, but they have multiple polar coordinates. So this is just important, like, to know. If you want to dive more into it, take complex analysis class, and they actually study pretty cool stuff related to this concept. Okay, so we're done with remarks. So let's move on. We're now do a lot of examples. Let's say it's going to be examples. So first is, let's sketch r is equal to constant and theta is equal to constant. And as an example, let's take r is equal to 2 and theta is equal to pi over 4. So please take your time to sketch these two graphs. and choose yes if you finish sketching in the poll. So the idea is like, we know that r is equal to 2 is going to be at least this point over here. And since we didn't specify what is our theta, that means any theta works. So right now I can choose any point which has distance 2 from the origin. And that is going to be exactly a circle. It's not of radius 2, it's going to be radius of square root of 2, but we're going to do that in a second. Okay, what about theta is equal to pi over 4? Okay, so this how we sketch like simple curves using polar coordinates. But let's right now do something interesting. Let's find their Cartesian equations. So does anyone have any idea what do we need to do to find the Cartesian equation? Yeah, so here, like, what do we need to do? Remember that we have really important formulas. X squared plus y squared is equal to r squared. And tangent of theta is equal to y over x. So if you have r is equal to 2, and you can see here you have r squared. So naturally, what do you want to do? You want to raise both sides to the second power. So you're going to have r squared is equal to 4. Oh, actually, yeah, it's going to be 2. Then r squared is equal to x squared plus y squared is equal to 4. So that's why that is going to be the Cartesian equation of this circle over here. So in other words, to find the Cartesian equation, if you're given the polar one, you just need to find how to get rid of r and theta inside your equation. But for this equation over here, it's slightly different. Here I'm going to use my second equation. I know that theta is always constant and equals to pi over 4. So that's why I'm going to write that tangent of pi over 4 is equal to y over x. But then I have that 1 is equal to y over x. So that means that y is equal to x. And that is exactly the equation of the line that have pi over 4 angle with the x-axis. Okay, so next example is the following. Sketch please these regions in Cartesian coordinates. So first one I want r between 1 and 2. And the second one, theta is between 0 and pi over 2. For the first region, you can see that my r is going to be bounded between 1 and 2. So that's why I know I have a circle of radius 1, and this is going to be a circle of radius 2. But my inside boundary is going to be solid, so I'm allowed r to be equal to 1. And my outside boundary is going to be dashed. So that's why the first region is going to look like a donut. Okay. For the second region, the same idea. Right now I have theta can change between 0 and pi over 2. So my points going to be between these two rays, green one, and r can be anything. So if since, oh, this one is interesting. If we will allow r to be anything, then we're going to have the first quadrant, yes. And can anyone tell me what else are we going to have?
The third quadrant?
Yeah, the third quadrant also, yeah. So, because if you allow r to be like positive and negative, then we're going to have a third quadrant. So if I want to have just the first quadrant, I need to specify that r is strictly bigger than 0. It's like to just get the first one. Okay. Okay, that's good. Let's see. Yeah, so let's move on to this. R is equal to theta. Oh no. So r is equal to theta is first like non-trivial one. So when theta is equal to 0, I'm going to have r0. When theta is equal to, let's say, pi over 4, then r is going to be equal to pi over 4. When theta is equal to pi over 2, then r is equal to pi over 2. So in other words, when we have 0 angle, we have 0. When we have pi over 4, my r is going to be along this red line. So I'm going to have distance of pi over 4. Let's choose this one. So let's call this point A, B, and C. So it's going to be A, B. And then theta is equal to pi over 2 is going to be along this green line. So pi over 2 is going to be here, C. So you can see that if you're going to increase your angle, then and let's set like theta be, so let's make r to be strictly positive. If you're going to increase your angle, then you're going to start from 0. And then every time your angle is going to increase, your radius is going to increase. So you're going to have this spiral. Again, I want to make sure that people understand. So please choose yes if like you understand most of it, not like all, but. So when theta, you're going to increase your theta, and your radius is also going to increase. So that's why you're going to have this spiral. Okay, perfect. So most people got it. So, and finally, the most important one that we need for the next section is to be able to sketch, it's called polar equations, which involves cosine and sine. So let's start with the most basic one. We're going to have r is equal to cosine of theta. So this one, I'm going to show you how to approach this problem. And then I'm going to give you a worksheet. And before tomorrow, I strongly recommend practicing sketching different trig functions. So we're going to sketch our trig function over here. Let's see. So remember, like during our first lecture, I said like it's important to know to understand like different functions, and probably the only place when you need to know what is a graph of cosine function is in this section. So the way how I like to sketch trig functions, I want to sketch their graphs in Cartesian coordinates. So in other words, I'm going to have theta and r. Okay. So first, I don't know like if you're taking notes right now or not. Can you please kind of guess or sketch what is going to be the graph of cosine function? So we're going to have cosine 0 is 1, cosine pi over 2 is 0, cosine pi is -1, then 0, then 1. So do you see we're going to have this way. Okay, and remember, like every time when you're going to fix on theta, well, this theta is equal to pi, then this point over here is going to be exactly your r. Okay, so let's do it. So the idea is right now I want to sketch this graph in polar coordinates over here. And that wave is going to describe how your polar version is going to look like. So let's do it together. When theta is equal to 0, then the value of your r is going to be equal to 1. Yes. So that means when theta is equal to 0, I'm going to have this point over here. So just give me a second. Cosine theta, yeah, is going to be equal to 1. So it's going to be here. And you can see when theta is going to go between 0 and pi. So let me indicate here 0 and pi over 2. Your radius is going to get smaller and smaller and smaller. So we know that this is going to be your pi over 2. So when theta is equal to pi over 2, I'm going to get 0. But you can think about this. You can take some point in the middle, for example, pi over 4, and you're going to find square root of 2 over 2. So when theta is going to increase from 0 to pi over 2, you're going to have kind of that arc. And that arc you can visualize this. You're going to just sketch a bunch of vectors from different angle theta. So do you see, like, when your red point is going to approach the origin, your red vector is going to get smaller and smaller and smaller. Okay. Can anyone tell me what is going to happen when your theta is going to change between pi over 2 and pi? Negative pi over 2 pi, we should graph something here, yes? So ideally, you can see when your theta is changes between pi or between pi over 2 and pi, your like arc is going to increase. But since, do you see over here, we have radius is negative. So that means that it's going to be reflected along the origin. So that means instead of sketching arc here, I will sketch arc over here. So in other words, I'm going to get this part. So that's why you can see how green curve in Cartesian coordinates is going to be like this curve in polar coordinates, and how blue curve over here is going to be blue curve over here. So let's call it like 1. This is 1. And green one I'm going to call 2. And this is 2. Okay. So can you tell me, like, then you can see from this picture that you need to change my theta between 0 and pi to cover the whole circle. So this is a circle. So if I'm going to cover this part of the circle, I'm going to trace it again. So when theta changes between 0 and 2 pi, I'm going to cover the circle like twice. Okay, so let's find the Cartesian coordinates of that circle. So we're going to take our equation, which is r is equal to cosine theta. And the trick is multiply both sides by r. I'm going to have r squared is equal to r cosine theta. And then remember that if we have r squared, then r squared is going to be equal to x squared plus y squared. And if I have r cosine theta, then that is equal exactly to x. So in other words, that equation r squared plus r cosine theta can be written as x squared plus y squared is equal to x. So the thing that you need to remember how to do is how to complete the square and to find the like standard version of a circle. So it's like x minus, so by the standard version, I mean you need to find of the form x minus a squared plus y minus b squared is equal to r squared. That is going to be a circle which is centered at point AB with the radius r. So it's going to be the equation of that circle. And to do that, what do we need to do with this equation? We need to complete the square. So I'm going to move x to the left-hand side. And then you can see I don't have any y values. So I need to complete the square for this component over here. But that is just a trick that I need to multiply it by 2, divide by 2 times x. Then I need to have my b factor. So I'm going to have plus 1 over 2 squared. But since I didn't have this factor, then I need to add this factor to the both sides. 1 plus 2 squared. And after that, you can use a formula that a minus b squared is equal to a squared minus 2ab plus b squared. And a and b in this case is going to be a is equal to x and b is equal to 1 over half. So I'm going to have x minus 1 over half squared plus y squared is equal to 1 over half squared. And that is exactly the equation that I need for my circle, because you can see that this circle is going to be shifted by 1/2 to the right along x-axis. So this point over here is going to be exactly 1/2 in 0. Yeah, so that is the equation. So let's do next one. So for the next one, r is equal to 1 plus sine theta. So idea is the same. Let's sketch sine function. So pi over 2, pi, 3 pi over 2, and 2 pi. So original sine function, I know how it looks like. It looks like this. So it's going to be this blue graph. But if I'm going to have sine function plus 1, that means what I'm going to do with my graph. So this is my sine theta. To get sine theta plus 1, I need to take this graph and move by 1. So this point is going to move to this point. This point is going to move to this point. This point is going to move this point. This point is going to move to this point. And this point is going to move to this point. So my graph is going to look something like this. So it's going to be the graph of 1 plus sine theta. Okay. And right now we can see how to use this Cartesian graph, theta and r, to sketch its polar version in Cartesian coordinates. In Cartesian plane. So when theta is equal to 0, I'm going to have that r is equal to 1. When theta is equal to pi over 2, because remember this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. When theta is equal to pi over 2, my r is equal to 2. When theta is equal to 3 pi over 2, my r is equal to 0. And when theta is equal to 2 pi, my r is equal to 1. So that's why I'm going to indicate point 0. I will have 1. Then pi over 2, I'm going to have 0.2. Then 3 pi over 2, I'm going to have, pi, I'm going to have, I skip pi, yeah. So theta is equal to pi, r is equal to 1. I'm going to have 1. 3 pi over 2, I'm going to have 0. And 2 pi, I'm going to have 1. So then you can see that if I'm going to change my theta and change between 0 and pi over 2, then my radius is going to increase. So that means here, like my radius is going to increase. It's like part 1. If I'm going to change my theta between pi over 2 and pi, then my radius is going to decrease. So this is going to be 2. My radius is going to decrease. And then if I'm going to change my theta between pi and 3 pi over 2, this is part 3, that my radius is going to decrease to 0. So it means I'm going to go from here to 0. And then the same if I'm going to change my theta between 3 pi over 2 and 2 pi, I'm going to increase. So you can see we got like this nice heart where, yeah, I don't know how to. It's beautiful heart with different colored sides. Okay, so I probably move a little bit too fast because we have like 10 minutes and I need to cover. I'm almost done. So before I'm going to move on, does anyone have any questions about this example? Theta dictates the direction, because if you have the origin, this vector is theta is equal to 0. So when theta, for example, is equal to pi over 4, we know that if your r is going to increase, that's why we know that we're going to move towards this direction. Do you see? We want to be able finding slope. So remember that we have that we can describe some curve as r and as a function in terms of theta. So for example, as we did, r is equal to cosine theta. And I can give you some point, let's say theta is equal to pi over 4, and ask to find the equation of the tangent line at that point. So how do you do that? So when you have r is a function in terms of theta, then your x is going to be r of theta cosine theta. And your y is going to be r of theta sine theta. And we know that to find slope, we just need to find the derivative dy over dx. But here right now, you can see that x and y are going to be a parametric equation where your parameter is theta. So what do? We just divide top and the bottom by d theta. Yes, so we have dx d theta. So in other words, we ask to find the derivative of r theta sine theta on the top, and derivative of r theta and cosine theta on the bottom. But derivative of the top, I'm going to use the product rule. It's going to be r prime theta sine theta plus r theta cosine theta. And derivative on the bottom is going to be r theta prime cosine theta minus r theta sine theta. So if I'm going to give you the curve and the angle, then right now you're going to be able to find the slope of that curve at that point theta. So in other words, I don't like memorization, so you just saw like how you can derive the formula at any point. You just need to know what to do. But if you want to memorize, then the formula is going to be r prime of theta cosine theta plus r of theta. Not cosine, this is sine. R of theta cosine theta. And here is going to be r prime of theta cosine theta minus r of theta sine theta. So I'm going to put this formula in the red box. And after this, we're done with section 10.3. Okay. So I'm going, okay, let's probably ask. I really like Polar because it gives me the opportunity to see like, otherwise, let's see. We have 4 more minutes. And let me just discuss one more concept. So for the homework problem, the worksheet, you need to know, if I, for example, will ask you to sketch this one, how this 2 affects the Cartesian graph. So the original graph of the cosine is going to look something like this. Yes, it's going to, we already sketched it before. So it's going to go like this. So it's going to be kind of that blue wave. Can anyone tell me what is going to happen with that blue wave if I'm going to add 2 in front of theta? So you can see that to cover this cosine to theta, if you have cosine of theta, then you need to change your theta between 0 and 2 pi here to get all the possible like kind of values to get the periodic function. Yes, but if you're going to add 2 in front of theta, then you're going to cover the same values if your theta is going to change between 0 and pi. So basically, you're going to take your cosine function and you're going to just compress it. So in other words, we're going to get something like this. So where this angle is pi over 4, and this angle is pi. Okay, and this angle is pi over 2. So, and then if I want to sketch this graph in Cartesian coordinates, I have x and y. Then we can see that if my, okay, I need to do it carefully. Let's sketch this between pi over 4 and pi. Let's take this segment. Pi over 4 is going to be this line. Then let's call this L1. And this line L2 is going to be here. L1, this L2. So you can see when my angle is going to change over here, first my radius is going to be negative. So that means I'm going to sketch my graph over here. And then my radius is going to go from 0 to 1 when it's equal to pi over 2. And then from 1 to back to 0 here. So that means my graph is going to go from 0 to 1 and from 1 to 0. And then if you're going to continue sketching, you can see that you're going to have that flower. In other words, why we're going to have that flower? Because if I'm going to just sketch this graph more, then you can see you're going to have 1 flower, 2 flower, 3rd flower, and 4th flower over here. Okay, so this was probably the fastest explanation how to sketch these trig functions. Don't worry if that was too fast. We're going to talk about it more tomorrow morning before we're going to start section 10.4. Otherwise, it's 10 a.m. We are done with our second lecture.